Okay, hello Team Impact. It's Monday. Going to get moving on into this packet. Um, so let me take a quick peek here and send me the lessons we have to get through. 8, 9, no, 9, 10. Okay, so we got a lot of work to do. I know there's another quiz in this, so we will have a quiz this week. So it's a pretty long unit. Um, so anyway, let's get started today. We're going to talk about nets, and a net is where you take a three-dimensional figure and fold it flat to a two-dimensional object. So essentially, we would take a box and then fold it flat. And that's essentially what a net is. And in class, I'll show you a couple of those so you can kind of see what's going on here, okay? All right, so let's go. A net is a two-dimensional composite figure. Okay. When folded, a net creates a three-dimensional object. Okay. So it would go back to the box. So this is a three-dimensional object. You can see the depth of it. And down here, these are two-dimensional. This box is folded out flat, essentially. So that's what we're going to be talking about, and we're going to be finding surface area on it. Okay. Use the nets below to determine which 3D figure would result from folding it. Then shade the bases. Okay, the bases. So when we look at this, all right, it looks like that we have a bunch of squares here. And when they fold all together, they're going to be a cube. Remember, a cube is all squares. Now, the bases, all right, a three-dimensional object identified by its bases. So here's a base it's sitting on. Here's a cube. And then here's a base. This would actually be the top, right? And this actually would be the bottom. Okay. This one, when we fold it up, this is a side, this is the front and the back, and here's the top, and there's the bottom. This is going to be a rectangular prism. Okay. All right. So let's identify the bases, right? The bases is what it sits on. So again, on a rectangular prism in a cube, it's very similar. This is the top and this is the bottom. Okay. Okay. So you clearly can see that this is going to be a prism as well. It's not a pyramid, but it's a prism. And this is called a triangular, all right, prism. Okay. All right. Now, we identify it by its bases, right? So this was rectangular. This was a cube because they were squares. All right. This is a triangular. This is actually now our bases. All right. This is kind of the bottom. All right. And this is a side. This is a side. That's a base and that's a base. Okay. All right. Next one up. Let's take a peek at it. All right, is a pyramid. Okay, so we identify the pyramids by its base. Now, a pyramid only has one base. All right, so this is going to be a triangular pyramid. There's the base. Okay, P-R-Y. Oh, sorry, P-Y-R. I'll be able to spell it's Monday. P-Y-R-A-M-I-D. That's why I teach math. Okay, so let's take a look at the next pyramid. We have a base, okay, and it looks like to be a square pyramid, right? It's a square. Okay, now look at the difference. If we were going to go find the surface area of this, which is what we're leading into, right? We would have to find the surface area of 3 triangles and the base. This, we're going to find 4 triangles and the base, right? Well, you guessed it on the last one. The last one's going to be a rectangular pyramid. Okay. Here's our base. Now we have 4 separate triangles. Now, if we were going to find the area of these, let's talk about these two. all right, I would find the area of this and double it for here. I would find the area of this and double it for this side. And then I would find the area of the base. Same thing here. Since this is a square pyramid, all I need to do is find the area of one triangle and multiply it by 4. All right, so if that made sense to you, great. Okay, nice little start to the Monday here. Let's go. Okay, next up. All right, so here's our three-dimensional object. They folded it flat to a two-dimensional figure. This is the net of the cube, okay? All right, so what's it say here for the directions? It says, use the measurements from the three-dimensional to label the dimensions of the corresponding nets. Okay. Well, since this is a cube, this is kind of easy to do. This would be 7, they're all 7, right? 7, and this would be 7. Everything is 7 there, right? So if I wanted to find the surface area of this, I would take 7 times 7 and get 49 and multiply it by how many sides are on a cube? 4, 5, 6, right? Sketch a net with 6 squares that would not result in a cube. Okay. Now let's see. I'm not real good at sketching, but I would do this, this, this. Okay, something like this. And there's a lot of different answers to this, right? And then I would put one here. And that's not going to work because we'll not close the back side. We have 2 fronts to it, or 2 backs, I guess. Okay, so let's take a look at our next object. And again, looks like we have a rectangular prism. Okay, and our long side is 10, so this right here is going to be 10 feet. Okay, and then, it looks like, all right, when we look at the height of this, it's going to be 2 feet, right? That's going to be 2 feet. Okay, and then the other piece is this is going to be 6 feet. So you'll notice that that is 6, this is 6. We can kind of go around the horn. That's 2, this is 2, 10, this was 6. You can label it however you wanted, but you're going to need to know those specific spots. Now, if we were looking for the surface area of this, I'd find the area of this and double it, find the area of this and double it, find the area of this and double it. Okay. Give 2 examples of when a net might be useful in real life. Okay. So, I'll give you one. Let's not worry about 2. But, all right, a net might help us figure out wrapping paper, right? Wrapping paper at Christmas. Okay. I can kind of figure out if I lay it flat how much I need by laying out my box as a net flat, and there I can't. So just one thing to look at. Next one up, number 9. Let me grab a cup to drink of coffee here. Looks like on number 9, we have a what? You should know it by now, right? This is a triangular prism. Now, we identify it by its bases. Here's a triangle, there's a triangle, and there they are, right? So let's go ahead and label it. Our long side here is 15. Okay. The slanted height, now, the slanted height is 6.5. And when this folds up to this is also going to be 6.5, okay? So you have to be able to transpose that. And then we give the vertical height, the perpendicular height of 6, okay? So a little bit different here. And again, depending on the type of triangle, all right, we could find the area of this a little bit different, all right? Sometimes it's isosceles, other times it's equilateral. Here it looks to be equilateral, so I'd find the area of this and double it. I would find the area of this rectangle and triple it. Next one up, Rico is asked to shade the bases on the net, and he shades the rectangles. Explain why the rectangles are not the bases. Okay, the bases must be opposite and parallel to each other. So this is opposite of this. This is a triangular prism. So this is opposite of this, and they're never going to touch. They are parallel to each other. So they must be bases, must be opposite, and parallel. Next one up, okay? We're going to go back to Egypt and go back to the pyramids, okay? All right, so look at this thing. Look at the net. All right, so now this looks like to be a rectangular pyramid because this is not equal to this, length and width. Okay, so let's go ahead and label this. This is the short side. It looks like 8. The long side is 12, okay? Now, we have to be very careful here, okay? This is a little bit different. On the long side, the vertical height is 8. So here's a long, there's my perpendicular height. It is 8. On the short side, which was 8, my perpendicular height, remember this triangle is congruent to this, is 9 feet. And I'm going to draw a line there as 9 feet, okay? So got to be careful with this. Now, this is different than a square pyramid. Okay, we would find the area of this and double it, area of this and double it, and then just find the area of the rectangle. So that's coming up. All right, Delilah says that a pyramid is unique because it has one base. Do you agree or disagree? Why or why not? Yes, I agree. It is unique, right? Pyramids only have one base and triangular faces. They have one base and they have triangular faces. Okay, so pretty basic lesson. We're going to get into the back half of this. If you flip it, you'll notice that here's your homework. Take your time. Do a good job. Identify these things. There's not much there. I'm going to set up a Khan Academy here in a minute for you. But there's only 3 pieces here. So let's get working on everything. And actually, Khan was set up on Friday. So it's Monday. I'm a little confused here. Anyway, have a great day, guys.